Cool. We have some folks from Surge here as well. And David will be moderating the chat. So if you guys have any questions, please feel free to use the chat. I'll if your questions will be answered like later in the workshop, I'll just mention it. Otherwise, if it's a quick question, I'm happy to answer it right away. So let's get started. Can everyone see the slides? Give me a thumbs up again.
Yes, sir.
Nice. Okay, cool. So some prerequisites that you might need for this workshop are some just like very basic terminal commands. I'll go over these too, but I won't be going into them in too much detail. Obviously, you'll need Git on your machine, GitHub, and Git Bash if you're in Windows. And I'll be using Visual Studio as my editor of choice. That's just my preference, but feel free to use any code editor, any environment that you'd like. So let's just get started right away on what is Git. So Git is a version control system. It's a way for you to create versions of your code so that you can collaborate on a project together with other people. Think of it like Stormy says here, think of it like a Google Docs, but made for code and better. There is a difference between Git and GitHub. Beginners often confuse this, and I just wanted to go over it. Git is a version control system, and so it can be used with various tools or locally on your computer to help you keep track of changes in your code projects. Whereas GitHub is a platform for code collaboration. So GitHub actually uses Git as a version control system. And as a platform, it provides you all sorts of awesome collaboration tools. So first off, we'll explore GitHub first. So if you guys can, I would suggest if you haven't made an account in GitHub, please do so. It shouldn't take you too long. And if you have, just go to your GitHub webpage, and I'm just going to go through some of the basic kind of features that the browser contains. The first one is called pull requests. So if you're in GitHub, it might look something like this. If you're in a repo, if you're in your profile, it'll look something like that. So you'll have your pull requests over here or over here. And so what pull requests are they're just a way to ask to make changes to the code by submitting your own changes for review. So it's kind of like a ticket, and you'll have some code edited in the file. And the pull request is a way for you to ask the owner of the code base to include your changes or to approve your changes. Next up, we have issues. Issues are a way to share a problem about the code without necessarily submitting your own solution. So if you go to the issues page, you can make other unique tickets. And so let's say you're making a website, for example, and you find out that something is not aligned properly. Maybe you're working on something else, so you can't fix it right now. So what you can do is just create an issue that says, hey, this isn't aligned properly. We need to tackle this later on. So again, you don't need to submit your own solution. It's just sharing an issue that you found in the code. And you can do this for other open source projects too. Folks love to hear about the issues just so that they can fix it up and make their project cleaner. Next up, you have your basic settings. You have like this bell symbol on the upper right corner. Those are just any notifications. Obviously, the plus symbol just allows you to create new projects or repositories. And then you have your avatar symbol that opens up further settings. That's kind of the basic overview of GitHub. Now we'll talk about repositories, and this is a term used quite often when you're using Git or GitHub. It's also called a repo, and it just means the project folder of where the code is. So it's just think of it as the project folder. That's what a repo means. So if you want an example, you can head over to this URL. I'll paste it in the chat. That's the repo that we'll be using for this workshop. Let me open up the chat. So you can make your way over there, and you'll come up to a page like this. So this is the repository, the project folder for GEAR201. Cool. I'm just going to summarize what a typical developer workflow looks like. Now, there's a lot of terms used here, and you don't need to know all of them. I'm going to go through them one by one, and I'm going to go through each step like via an example later on. But before I do that, I just wanted to give you an overall summary so you have like the big picture idea of what the workflow for common developers look like. So let's say you're this is not a code base that you own. So for example, the GEAR201 repository, it's not something you guys have created yourself. It's something our team has created, but you can still make contributions to this code because it's a public repository, which means it's open for other people to request to make changes and edits to the code. What you'll do first, the first step is you'll fork someone else's code. Fork means you're creating your own copy of someone else's repo. Then you'll create a branch. So let's say for our code, there was some feature that you guys wanted to work on. You would fork it first, copy the code, then you'd create another branch. A branch is a parallel version of the main copy of a repo. So making a branch allows you to edit the code without accidentally breaking the working version. Then step 3, you stage your changes as you go. So once you've made your edits to the code, once you've added or included your feature, you stage them. Then when you're happy with all the edits you've made, you'll commit them. So stage means you're adding to a cohesive group or bundle of revisions. So as you're making edits, you're just saving it locally and you're staging them so that they're ready to be committed. And then when you commit, it means that all the changes you've made, you've officially added it to your branch in your repository. And I'll go over more of what this means later on. The final step is, step 4, you'll want to add your code to someone else's project. Again, you were working off your own copy, your forked copy. But since you want it to be included in the main project code base, you'll open a pull request where you're asking for your code to be reviewed so that it can be integrated to the main repo. And if they approve it, they'll merge your branch into their main branch. And so merge is to officially add the changes from your branch into the main branch so that the edits you've seen is seen also in the original repo. So, okay, I'm going to go through this step by step. A lot of terminology used here, but I'll break it down. So first off, if you haven't done so again, head off to the GitHub GEAR201 repo, and then you'll fork the repo. And so how you fork the repo is you just go to the upper right corner and you press fork. And that should, right here, that should lead you to forking it under your name. So give me a thumbs up if you've done that and you're good to go.
Pranir, we just have a question in the chat.
Yeah, go for it.
If you merge branches, will one override the other?
If you merge branches, will one override the other? So when you merge branches, you're basically integrating what you have in the one branch into the other branch. So again, branching works in like a one-way level. It doesn't merge in like so that both of your codes create another branch. It's hard to show here, but essentially, let's say you have your development branch, and then you have your feature branch. Whatever edits you've made into the feature branch, it's integrated into the development. So the development branch will contain the edits you've made in the feature branch, but the feature branch will not contain anything new from the development branch. Hope that answers the question. So it won't necessarily override one another. I don't think that's the word I would use. It's more you're integrating it into the branch that you're merging into. Good question. Cool. Step 2, again, step 1, we forked it. Now we're going to create a branch. So why you want to create a branch is because when you fork the project, you forked what was recently known as the master branch. Now it's known as the main branch. So you've actually copied their main version. And what you want to do is you want to make a branch because the main one contains code that is working. And so let's say you make edits to the main branch, but there's a bug and your code isn't functioning anymore. It's hard to go back to the time where it was working, to the version it was working. And that's why you usually create branches in order to kind of safeguard that working version, so that if there is a problem, you can always go back to the version that's working. So step 2, we'll create a branch. And this, again, we're not using Git right now. We're only using GitHub. Just want to make you guys comfortable using GitHub. So just click on something like here, and then just write a branch name, and then hit enter. I think I've already forked my repo, so I will go. So just here, any name you want. Here I've done add grocery because that's what we're gonna do. So just type in the branch name and then hit enter, and then that branch name should be created. And once you've entered, you should also be in this branch. Like this would change to indicate which branch you're on. I'll show you what this website is about. So it's a very simple static website. This is what you'll be adding into. It's just Stormy and Sparky's grocery list. And so you'll just be adding items of your own. So that's the goal of this part. And so once you've created your branch, the next thing you want to do is you want to actually make those changes where you're adding into the grocery items. So open the file that's called app.js, and then click on the edit icon. It's in the top right corner. Once you've opened the file, it should appear. It's a pencil icon. So app.js, and then you can make edits to the code. And then go ahead and then write any grocery item that you'd want to be added to this list. And we'll test it out. So again, there's that list of groceries. Just follow that formatting. Just put like a comma, and then in quotations, write any item you'd like. You can write multiple items. You can just write one. Doesn't really matter. Once you're done, scroll to the bottom, and then it should say something called commit directly to your branch, and then commit those changes. So here we're going through step 3, where you're staging your changes, and then you're going to commit them once you're done making all your changes. Let me know when folks are good to go. Just a thumbs up, and then we'll move on. Awesome. Looks like most people are done. Cool. Once you've committed your changes, Now you need to make a pull request. So you've committed it into your own forked repository. So you've committed your changes into your own copy, but you want those changes to be reflected onto the original copy, right? So that's when you create a pull request to say, hey, I've made some changes to the code that I want to see added to the main repo. Here's the edits that I've made. And that's what the pull request sends to the owner. So head on and if you go back to your code file, so to your main repo page, there should be something called this compare and pull request that comes up. Don't click on the green one, but click on the one below. There's this gray one. Let me know if that comes out and if you've clicked on it. I'll make it a little bigger, just like that. Awesome. Once you've made the pull request, something like this should pop out. And because this is a simple pull request, you can just click on the create pull request. But if you were contributing to, let's say, an open source project, like a more official project, you'd probably want to be very descriptive about the changes you've made, just to make sure that the owners know what you've done and what you were trying to do. So in this title section, I've just, for my commit, I just said add oranges to the grocery list. It's just a very small comment. You can change that to whatever you'd like. Again, if you're contributing to a more official code base, you'd probably leave more comments. And here you'll actually see where you're sending in the pull request to. So you're actually comparing this feature branch that you've made, whatever name you've made it, and it's under this repository, which is your forked repo, and you're pushing that or making that pull request to the main branch of the surge repository. So let me know when you've created that pull request, and then I'll show you what it looks like on the owner's side when they receive the edits that you've made that you want them to approve. Cool. So once that's done, what I'll see is oh, 10 pull requests. Awesome. So these are all the pull requests that you folks have made. I'm just going to go from the beginning. So you'll see here they've made some edits, and you can see the files changed by clicking on this tab, and you can see that they've added bread. So green means that they've added something, and then if they've deleted something, it should come up with a negative sign, and it should be red. So here they just changed one file, and they've made one addition, which is the bread. So this looks good to me. And so what I'll do here is I will, I'll approve this. And so whoever this is, if you'd like to, you can merge this pull request yourself. I think it might come up in notifications. Let me know if you can go to the page. But you should be able to go here and see that your changes were approved, and you can merge it. Let me know if you're able to merge it. Otherwise, I can do it on my end too. Nice. Yeah, so you can go on ahead and click merge pull request. So once changes are approved, before it was red because I'm the owner of this repo, so I hadn't approved it yet. But once I've approved the changes, the person that's made the edit can merge it. Let me know if you are able to merge it. Otherwise, I'll just do it right now. I will give you around 5 seconds. All right. I'm just going to merge it for you if you don't mind. And now if we go back to our main repo, we go to app.js, we should see that bread was added, which is awesome. So basically, again, you wait for the person to review it. And I'll talk more about when you're actually making your own repo a little later, because you'll have to review the changes. Since you own the repo, you'll be reviewing the changes as you go on, especially for the hackathon. And then you can merge the pull request, and then integrate the edits you've made onto your main branch. So there's something called conflict resolution. This happens when you can't merge files. So it's called a merge conflict. It's when a file has multiple edits and it can be unclear which change should be committed. And so this is a conflict that must be resolved before you merge. And so if I do go to another pull request here, so let's say I go to the tomatoes one. I go to, here you can see that I can't merge it because there's conflicting, there's a merge conflict. And this exists because when you guys made edits to the code in the beginning, this bread didn't exist, right? But now, since the bread, this bread grocery item has been merged into the main repo, GitHub gets confused about, hey, like, is that bread supposed to be added or not? Because when the person here made his edits, we'll go here, you go to resolve conflicts. So you can see that the bread exists and GitHub is just confused about whether that bread is supposed to be there or not, because when they had created the branch, that bread did not exist, right? And so that's why there's a merge conflict there. And so you can deal with merge conflicts right in GitHub. Since in this case we want both, right? We would just delete these lines, fix it up like that, and then you just do mark as resolved. And then you can commit the merge. There you go. And now I can actually review it because now it's okay. See, now there's 2 changes. That's just resolving the conflict. If I approve it, the person that created this pull request can now merge. So I'll leave it there. And if you'd like to merge your branch, please do so. I'll get into more. So pull requests, you can do it via GitHub. You can also do it via your code editor. So I'm just gonna, let's say I merge this, and let me go to another pull request, add toast. I don't think toast is a grocery, but maybe it is. Anyways, if you want to do this in, like, let's say your editor, GitHub is actually super nice because you can like either do it in the GitHub desktop, it gives you options. And if you want to do it in the command line, it gives you the commands that you should run. And so if you open up the terminal at your repo, you can run these. So you would check out, and we'll go through these commands a little bit later, but I'm just letting you know that through GitHub, they have some awesome features to help you out, to help you guide about how to go with merge conflicts and how to resolve those conflicts. Cool. So that's kind of GitHub in a nutshell, and that's probably the features that you'd be using the most, especially in the hackathon. So you'd just be sending in those pull requests with your edits in the code, merging them so that your main project repo, the main branch, is being updated. And now we're going to move on to oh, this is just a video of the conflict resolution. I'm gonna skip it just because we did it live. But yeah, I'll have these slides posted. So if there is, if you do want to know how to resolve conflicts, you can run through this video. We'll go to Git. So just make sure that you do have Git installed. A quick way to see if you do have Git on your machine is to just go on your terminal, and my terminal loads up. Can you guys see the terminal? Any thumbs? Or just any confirmation? Nice. Okay, so if you just do git version, you should see some version come up, and that just means you do have Git. Otherwise, just go through this link and download it. If you're on a Windows, I would suggest you to get Git Bash. It's super nice because it's just an application which provides an emulation layer for a Git command line experience. So it provides an emulation of the Linux shell. And Bash is an acronym for Born Again Shell. So you can go to that link to download it. I'll post it in the chat if that's easier. So that's just for Git. And then if you're on Windows. Awesome. Okay, so if you have Git, first thing we want to do is see if we can configure it just with your username and email. And you'd probably configure it with the same credentials you have for GitHub. Just makes it aligned so that they can pass information quickly, or they can connect. And how you do that is you just run these commands, the git config -- global user.name, and then write your name. I use quotations here because there's spaces. If you're just writing like one name, like your first name, you don't need to put spaces. But if you have any space, put it under quotations. Do the same for email. And then to check if those have been added, you can just do git config user.name, and then you'll see your username come out. The same for email. Cool. And these are just commands to help you learn more about Git, just in the terminal. So if you do git config -- help, it'll give you a list of commands that exist, and then it shows you what all these commands do. It's very detailed. If you want a more summarized version, you can just do git config -h, and it gives you like a one-line summary of what the command is. So those are just tools to help you out if you want to learn more. Again, this workshop, we're definitely not covering everything. It's just an introductory level for you to understand Git, and some tips that I want to share so that you can effectively use Git and GitHub in the hackathon. So when learning about Git, I think the best way to do it is the visual representation, because a lot of beginners get stuck on like how it looks like and how is the version getting controlled. So I'll go through this very slowly. Like if you understand this, understanding any of the Git commands will come as a breeze to you. So we created, this repo here on GitHub is called the remote repository. So the project folder essentially on GitHub is called the remote repository because it's the project folder in the GitHub server. And so the stuff that we have here, like all of these files that we have under GitHub, that's the remote repository. The files that you have in your computer, they're called the local repository. So how Git works to track versions is you have the remote repository, and then each computer has their own local kind of copy, right? And under that, you have your working directory, which are just the files that your code exists in. And you also have a local repo. And so the local repo communicates between the remote repo, and they pass information of the versions and the changes you've made to the code. So Git is called a distributed version control system. It's called decentralized, my bad. Decentralized version control system. And that means because it's held on a server, each person has their own local copy, but each local repo connects with one remote repository, and then you trade information there. Does that make sense? Everyone on the same page? Any questions there? Awesome. Nice. Okay, so what does the individual workflow look like then? So we went through kind of like the developer workflow, but this is the workflow when you create your own repo. So what you do first is you can clone your repo that you have access to. And so clone is similar to fork. You're copying a repo to your computer. Then you do the same step, you create a branch, and well, we'll go through these commands later on in more detail, but there's a command called git branch, and then you just name the branch that you want it to be named, and then you'll create a branch. After you make changes to the code, you'll use git add to stage your changes, and stage means you're saving your changes so that they're ready to be added to your branch. Then you'll use git commit -m. -m is just a flag for a message. So that means that whatever comes after m is a message explaining your commit. So your commit message doesn't have any effect on your code. It's just a comment. So it can be like git -m added a grocery item, whatever. And then you'll use that to officially add changes to your branch. And then when you're ready to push your local changes to your repo on GitHub, which is in the remote repository, you'll use git push. So you'll add the changes from your local computer to your GitHub repo. Then it's the same two steps. You can make the pull request and then have your PR merged on GitHub like before. But now you also have to use git pull because when you use git pull, you're adding those changes from the server, from the remote repo to your local repo. Again, a lot of information here, and we'll go through this in detail step by step. So don't worry if you look like this. So if we go back to the visual representation, let me do this. So you have your local repo, you have your remote repo on GitHub, right? When you clone your repo on GitHub, so in GitHub you create, so first initially you create your remote repository. Nothing here would exist. Nothing on your computer exists until you've cloned it. Once you cloned it, then you set up your local repo and you have your working files. Once you've made your changes, you do git add, which adds them to the staging area. And so they're ready to be committed. And then you would run git commit. And git commit is when you officially add any changes you've made to your local repository. Once you do git push, you're actually pushing the changes you've made, and you want it to be seen in the remote repository. And so that's what's happening here. Now, since you've been working, when you're working with Git and GitHub, you'll be working in branches, right? Because you don't want to impact the main branch. And I'll say this at the end too, but you really do want to protect your main branch because you want to make sure everything is working there. So whenever you're making features, and you can create numerous branches, just create a branch for one specific feature. It's a nice workflow. Once that feature is done, you add, you commit, you push, and then you merge. Once the feature looks good and it works, you merge it into your main branch. But again, when you merge it, it's only reflected on the remote repository, right? So your main branch in your local repository hasn't been merged with your new feature branches. And that's when you run the git pull command. And so what this does is it updates, because it's been reflected here, the code has been merged here with your new feature, that gets updated to your local repo and your working directory, so it's reflected on your local machines as well. So that's kind of the visual representation of what the workflow with Git and GitHub looks like. And so we'll go through this example. So what we'll do is we'll create a repo. So on the upper right, there's that add button, the plus icon. Just click on that and create a new repo from your profile or homepage on GitHub. Name your repo whatever you want, write a sentence describing it, and then just most importantly, just initialize that with a README because that's what we're going to be editing. If this were a project, a code project, you would probably add a .git ignore or a license, but we're not going to go over those today, so you can avoid them. And then just head on down and click create repo to create your new repository. And then give me some thumbs up once you're done. I'll do the same. Cool. So once you've created the repo, you'll be pulled into something like this. I'm going to go back to the slides just to show you that now you've created your remote repository. So this is what you've created right now. The next step is to clone your repo so that that remote repo that you've created, you want those files to exist in your local computer so you can make changes in your computer. So there should be a button called code. Just go down there, copy. There's a clipboard icon. Copy the HTTPS, and then go to your terminal. Go to where you want to clone or make that file appear, and then just type in the command git clone, and then paste that URL. So right here, copy, and I am going to go to paste. And then you should see something like this come up. So Git cloning, why is it important? Like, why wouldn't you just download your files? The thing with Git clone is you did not just download the files that exist in the repo. You cloned it. And so a Git repo comes with a special hidden folder called .git. You don't need to know anything about this folder. You won't be making any edits. It's just nice to note that this is the folder that connects your local project to the remote project on GitHub. And so you can actually explore this. So if you go to your project folder, I forgot what my project folder. So once in your project folder, you can run the command called ls. If you run ls, it shows you only your non-hidden files. But if you do ls-a, it'll show you all, like even the hidden ones, and you'll see that .git file. And so when you clone your repo, that .git file exists as well. And that's why it's important not just to download your files. Otherwise, there's no connection between this local repo and your remote repo. And that's why cloning is important. So we've cloned it, and now we want to add in our changes. What we do first, to do any changes, you create a new branch. So git checkout -b is to create a new branch. You never want to commit directly to your main branch again. You also did this in the browser using GitHub before, where we just went like this. You typed in your branch, you created it. That's one way to go about it. But if you want to do it in the terminal, what you can do is you can just run git checkout b, and then I'm just going to write update readme. So here git checkout means you're going into a new branch, and then the -b is saying, I want this new branch, this branch to be new. So I want the branch to be created, and then I want you to go into that branch. It's basically combining, it's a shorthand for combining two operations. So what you can also do is you can also do git branch and then branch name. You create a branch this way, and then you can do git checkout to the branch name you had. But if you want to do these two commands at the same time, like let's say you want to create a new branch and then go into it, you would just do this. So just a shorthand. Awesome. So you've created your new branch, so you can make a change. So open the file, the README file in any text editor that you want. Again, I'm going to use Visual Studio. So I'm going to go to, let me open a new folder. Awesome. Oh, that's the wrong folder. And then go to your README and type in anything you want, make any edits. Right. You made edits. What I do like about Visual Studio is that it'll actually show you the changes you've made right on the editor, which is kind of nice. And you also have the terminal in within the environment that you can use, which is also super cool. And so once you've made those edits, you can input git status, and that will show you like what's been modified in the code. And it also tells you that nothing has been added to commit. So if you run git status here, you've made those changes. If you run git status here, you'll see that it says you've modified the README file, but no changes have been added for you to commit yet. So we have to run the same 3 commands to push those changes. You do git add first. And so this command, again, gets your changes ready to be committed. It stages your changes. You can do git add and then the file that you modified, or you can also write in git add dot or period. If you write this, it just means to change stash all the changes in your current directory that you're on. So all the files within this directory, it would stash them. It's just a neat way. So if you've made multiple edits, instead of writing down all the file names, you can just do git add period. And what's nice about Visual Studio, again, is here, when you've made those changes locally, you'll see that it appears as changes. And when you've added them, it'll go to stage changes. So these changes have been staged and now are ready to commit to be officially added to your branch. So again, if you hit git status, now it'll be in green. It'll show you that this is the file that's been modified. The changes have been added and they're ready to be committed. So to commit your changes, just went through that. To commit your changes, you'll often include a commit message. It's just a message that describes the changes you've made. Also standard practice for your first commit to be first commit or initial commit. So we'll do that right now. Git commit -m, again, that flag for a message, and then just write any message. And you'll see in Visual Studio that it actually disappears once you've committed it. So it's been added officially to your branch in your local repository. So again, if we go to the visuals, it hasn't been added here. It's only been added to your local repository within your computer. And to send that there's been updates to the repo that we want to be added to the main branch, we push that to the remote repo, and that's when you run git push. So when you run git push, you'll see this message that comes up. GitHub is super nice because Git will actually tell you the correct command to run. This is just because there wasn't a branch, it wasn't specified which branch it's following. So if you just copy paste that, it should run fine. So copy paste that. And now you've pushed those changes to your remote repository. Next two steps, pull request and merge, right? So go to the pull request and you'll see that you've made changes. You just click on compare and pull request because this is your own repository. So if you click on the compare and pull request, you'll see this come up. You want to make the changes directly to main. That's the branch that you want to update. So you create that pull request, and then you can go to files change. You don't really need to approve it because it's your own repo this time. So you can just directly merge. And now if you go back to the code and go back to the main file, you'll see that this has been added. That wasn't there before. Right, so pull request, create that ticket to update, and then merge. And now this is where it gets interesting. So the main branch for your remote repository has now been updated with that new edits that you've made. But if you go to the remote repository, if you go to the main branch in your local repository, so if I do git checkout main, you'll see that it doesn't exist, right? And that's because you worked off, again, from another branch. This branch was working fine, but you made another branch to protect your main. You worked on a feature, you made edits, you merged that into the remote repository. And now you need to see those changes be reflected on your local device too. And that's when we're at this step where we're running git pull. And so we're asking the remote repository to send in those changes so that we can update our local files and our local repository correspondingly. So if we just run git pull, you'll see that it's been added. And that's pretty much it. So you'll see your changes in GitHub, and you'll also see your changes in your local repository. And that's kind of the whole workflow that you'll be going through in the hackathon when you're making changes, when you're adding in your changes. That's about it. The best way to learn about Git is to just experiment. There's going to be things that, don't work so well, but don't be scared, especially for Stormhacks, because we have a lot of mentors that have used Git for years, and they'll be there to help you out whenever you do need help. Any questions about the basic the basics of Git and GitHub before I move on to more of like the tips and tricks that you might come in handy for the hackathon especially? Any questions, David? Cool. Okay, I'm going to move on to some some workflow tips for GitHub first. So the first one is usually, and this is what SFU Surge followed as well when we were developing our website. So our team developed this. And so a GitHub workflow that we utilized was called when we created a dev branch to protect the main. So we actually never committed into the main branch. So whenever we made feature branches, we would always push those changes into the dev branch. And that way your main there's like an extra layer of protection for your main. So you by following this workflow, you only allow dev to push to main, And that way, you know that you don't push the main until you make sure everything is working in dev. And so when you do push into main, you can release like versions, because again, follow that rule that says everything on main should always be working. I think this would also help you out with the hackathon, just because 24 hours, again, is not a lot of time to come up with a project. So this extra feature, it allows you to have a working version at all times. So when you have that dev branch, it's to protect your main. So if something does go wrong, you can always go back to the dev and fix it, and then you'll have a version that's been working. And it's also easy to debug, because you can look at the changes in dev and look at the changes in main, and then you can compare it to see where you may have gone wrong. It's easier for debugging as well. Another thing is branch protection rules. This is just good practice. So if you go to your GitHub, and in any repo, if you go to settings and you go to your branches, you can actually set up branch protection rules. So what I would suggest you to do is to create protection rules for main and your dev branches. So just put main there, and then you can require a review, and you can change that amount. I would suggest for the hackathon just to put 1. That's fine. So it makes it efficient, but it also makes it so that another person has to go through the changes you've made. And so again, that's just another protection rule, and it's also good practice, just in case that you do have some bugs or there's something wrong with your code. Someone else looking at it, just a secondary pair of eyes, is always helpful. Manage access, that's another setting. So if you go to within settings, if you go to manage access, you can always create like a team and invite collaborators using their GitHub username, and that way they'll have direct access to the repo, and it's just easier for everyone to contribute and push changes because they'll have access to your repo. That way they don't have to fork it, and they can clone. So it makes them part of that organizing team of the repo. So that's kind of just like the very simple GitHub workflow tips. And then I'm going to go through now some tips and tricks with Git. So there's something called stash. This is interesting because in Git, essentially, when you're working on a project, like let's say you're working on a feature, right? So, okay, I'm in main right now. Let's check out to another branch. Let's call it new branch, right? Let's say I'm in this new branch and I was adding some things in. I don't know what to add in. Kiwi. All right. So let's say I was adding something in, but I wasn't done. I had to make changes, but then there was something else that I needed to do, right? But I don't want to delete this. But what GitHub does is it doesn't allow you to check out to another branch without committing the changes you've made first. So if you check out to another branch without committing or stashing this, the edits you've made will be deleted, right? So what you want to do is something called git stash. And what git stash does, it just temporarily saves. It's just like a snapshot of what your code looks like in that moment, and you can go back to it later. And so let's say there's a bug that my team found out that was more concerning that I had to look over. What I can do is I can just run git stash. I could just run git stash and it will stash it, but I would recommend using this command called git stash save. Just with the save, you can actually write a comment. So you can just be like added kiwi. And so it's easier for you to know what snapshot that was capturing. So if you do that, you'll see that the kiwi disappears. And then you can check out to another branch, new branch, and do whatever. Oh, already have that branch. Okay, let's say we check out to the new branch. Do whatever you need to do there. Say you've made those edits, and now you need to come back to the branch that you were working on. you can hop in the command git stash list, and it will show you the stashes that you have right now. Right. So right now I have 2 stashes. This one I made a long time ago before. And what you can do is you can just do git stash pop. What git stash pop will do is it will take out this stash. So it'll take out the first stash, and it'll apply it. So if I do git stash pop, you'll see that this comes back in. Oh, there's bacon and kiwi. Let's just accept both. And so your kiwi thing is back. And if you go to git stash list, a pop gets that, but you can also do git stash apply and copy paste the exact stash you want to be applied to your code. Cool. So that's kind of how git stash works. It's just a way for you to temporarily save a snapshot of your branch, just in case you have multiple branches you need to be working on. Because again, Git doesn't allow you to check out to another branch. So be careful with this, just because if you do check out to another branch without committing, you might lose the edits that you've made. So if you are making new branches when you haven't commit or pushed or staged those changes, just be careful about doing that, just because you can lose those edits you've made. And you can drop the stashes. So let's say you were working on the same feature, but you had 2 different ideas of how to go about it, and you had 2 different branches named. You figured out that one branch had a better solution. You can do git stash drop and then copy paste the stash with the number, and that will remove that stash. If you want to lose or clear all the stashes you have, you can just run git stash clear, and it'll remove all of the stashes you saved. The last one is undoing things. So this is probably something that a lot of people ask for help in, just because there might be things that you've done and you want to restore it back to its state before, because you've done something and it was a mistake. So let's say you've made a change and it was not like a proper code, it was a bug, and you accidentally added it, right? So there's 2 ways to go about it. If you're in Visual Studio, it's super nice, because if you want to undo that add, you can just press that subtract symbol and it'll undo it and it'll go back to changes. So again, it was in staged, and you can press that minus sign in this version control bar, and it'll go back to the changes. But if you want to do it in your terminal, there's also a way to do it. It's just git restore. So it's called git restore staged, and then you can write the file name, or you can just do period to restore all the files. So you undo the change, undo the add, so it moves back to the change. Now, what if you've done the git add and you've accidentally committed as well? Right? Oh, dash m. So let's say you've accidentally committed, and that's gone now. So you can't really undo it here. You might panic, but you don't need to. There's something called git reset head that will undo that for you. But be careful with using git reset head. There's 2 commands you can use. There's git reset head 1 soft, and then git reset head hard. If you do the hard one, it will not just go back to so it'll go back a commit. That's what the reset head does. It goes back 1 commit. But when you do it hard, it will remove the edits that you've made. So for example, let me do the soft one first. The soft one does the opposite. So it keeps those changes, but it does go back the commit. So if you want to keep these changes, but you just want to go a commit back because you forgot to add something, you can do git reset head, and this number just indicates the number of commits you want to go back. And so for us, it's just 1. If you do soft, you'll see that it comes up to the staged area and you still have this, right? But let's say for the hard, it actually removes the changes we've made and goes back to the previous commit file. So there, it removes those changes we've made. So be careful with the hard one if there are changes that you've made that you didn't want to lose, So I would just suggest using git reset head with soft. And there is an undo to the undo. So let's say you git reset and that was wrong. You weren't supposed to do that. So you've gone back to a commit, which was not the correct one. You can just do git reset and run this command instead. And then it'll like recommit, it'll go forward. Cool. That's my tips and tricks about Git and GitHub. I'll be around for a couple of minutes if you guys do have any questions. But thank you so much for coming to the workshop, and I hope that gave you an idea of how Git and GitHub works, especially the topology. This thing is good to wrap your head around just because you learn Git a lot faster when you understand the rudimentary basics of how the system is communicating or connecting. I'm going to go through the chat now, but if you do have any questions, feel free to also unmute yourself and I'll be around. Again, I'm not an expert in Git. I'm still learning about it. You'll learn about Git a lot in the hackathon. That's one place where you learn about Git a lot because you'll be using many commands. The ones that I did go over, you'll be using that continuously and constantly. But if you do need references, go to the Git doc. They have some great support tools. And if you want like a Git command cheat sheet, there's multiple in online that you can pull out of. Atlassian is a great resource to learn Git. But again, I'll be here for a couple of minutes if you guys have any questions. And once again, thank you so much for coming to GEAR201 to learn more about Git. Hope that was helpful. Thank you. I'm gonna go back here. Yeah. I'm gonna stop recording now.